Hi guys, we're going to do our next video. The first thing you should be thinking to yourself though is, do I have these things done? Did I correct my redox test? Most of you had barely anything to do, but everyone needs to correct these, and I have a video posted. Should be very easy. Did you finish packet page 19 and 20 in class today? That needs to be done. Did you finish textbook page 177 to 187? That doesn't look right. 177 to 178. That'd be a lot of pages. 177 to 178. Do you have that done? All of those things need to be done for Monday. Those are things that we had time previously in class to do, but not everybody finished all of them. What we need to talk about today would be how to identify compounds as being acids, bases, or salts. So we're going to our packet page 14 in the acid-base tab. So when I look at acids, bases, salts, I want to also tell you about organic alcohols. We have to be careful of what we need to look for. So I'm going to go through these one by one. So first let's start with acids. Acids usually have H+. They usually have H+. An example of that would be an acid like HCl. Hydrochloric acid. Additionally, I want to know that my special acids, my organic acids, which we will learn much more about next unit, are things that have COOH, COO. Remember we talked about that a little bit in class, but that COO is special to an organic acid. Notice it's got an OH, but it has another O. So two O's, an H, and a C. You see that like that? It is an organic acid. An example of that might be CH3COOH. Because I see that COO, I know it's an acid. Also, to identify an acid, you might want to think H is written first. H is written first. For example, let's say nitric acid, HNO3. HNO3 is an acid. If I look at something like KH, that is not an acid. This is called a metal hydride. A metal hydride. That is not an acid. So you want to notice that I have H written first. Here I have H in front. Here I have H in back, which alerts me to that's not an acid. So now, if I'm thinking about my bases. My bases, we'll do those in blue, are things that have OH minus. They have OH minus, also known as hydroxide. An example of that is NaOH. Also, bases could have an N. They could have N. But make sure it's not part of a polyatomic. It is not part of a polyatomic. So like I gave you the example for my acid of HNO3. It had an N in it, but that's part of a polyatomic. I'm talking about things like NH3. That is a base. I can find that on table L, and that looks a little funny, but it has an N that's not part of a polyatomic. That is a base. When I'm thinking, what is a salt, an ionic salt? Well, it's anything that's ionic. So ionic salts are going to be when I have a metal and a nonmetal, generally. Something like NaCl, you know that's called salt. That would be one. Another example, if I had CaCl2, boom, that's another salt. I could also have a metal plus a polyatomic. I could have a nonmetal and a polyatomic. Either or. So for example, if I had like MgSO4, metal with a polyatomic, if I had NH4Cl, polyatomic with a nonmetal. I could also have two polyatomics. For example, let's do NH4, NO3. NH4NO3. So basically anything ionic is when I'm going to have two ions. But those ions, they cannot be H and they cannot be OH. Any other time I have two ions combining, I am an ionic salt. And lastly, I have my organic alcohols. My alcohols, as you'll remember, are always going to have OH, but it's always going to be with carbon. With carbon. So for example, we have CH3OH. That has an OH group on it, right here, but it also has a C. Don't let them trick you. That is very, very common for them to put those there, and they hope that you say it's a base. It is not a base. It is an alcohol because it has a C and an OH with it. Also notice the difference between that and an acid. The organic acid, they are very similar. Be careful. This is not the same as this. They are different. And the difference is that O. COOH is an acid. C and just an OH, that's an alcohol. So at the bottom of this page, what we want to do is classify the following as being an ionic salt, an acid, or a base. I'm noticing somehow, oh yeah, let's move these answers out of here. Oh, did you see them? Did you look quick enough? Oh, did you look back? Yeah. But what I want to do is I want to make sure that I decide what these things are. So for instance, number one, K is a metal, I is a nonmetal. So I have a metal and a nonmetal. So this is an ionic salt. If I skip down to something like number 3, I see an H in front. That means this is an acid. If I do number 4, I see an OH. OH is not with a C, and I don't see another O, so this must be a base. But number 5, when I look there, I see OH, but I also have a C. This is an alcohol. What I want you to do is I want you to go through this page and identify them. Is it a salt? Is it an acid? Is it a base? I want to know which category it fits in. You should pause the video now. Okay, so hopefully you finished that section. We'll be going over it in class. We're now going to introduce, actually you see K and L there. I also am going to introduce this new table, Table M, your common acid-base indicators. So Table M will be our new one. You should get a reference table by you. And we're going to talk about that. We're also going to flip in our packets, and this is your page 9. Your packet, page 9. We're going to talk about our pH scale. Then we will get to our indicators. So what I first want to talk about is the pH scale, how it goes from 0 all the way up to 14, with 7 being in the middle. 7 is considered neutral. 7 is considered neutral. If I am above 7, 7 and above, I am a base, or I'm basic. If I'm below 7, I'm an acid, or I'm acidic. So below 7, I'm an acid. Above 7, I'm a base. And 7, I'm neutral. What happens is I want to think about, well, what does neutral mean? We actually learned about neutralization reactions, which is when I mix an acid and a base. And neutral, most people will be able to tell me it starts at 7. What you're really saying there is that your H plus concentration, those little lines is how you say concentration, is equal to your OH minus concentration right at 7. If you're at 7, your H plus equals your OH minus. If you're acidic, you want to think acids have H. So that means if I'm acidic, my H plus concentration is actually greater than my OH minus concentration. I have more H plus than I have OH minus. If I'm a base, well, bases have OH. So that would mean that my H plus concentration, I actually have less of it than my OH minus concentration. So when I'm a base, I have more of my OH. When I'm an acid, I have more of my H. And when I'm neutral and I'm 7, well, I've got equal. I do want to also remind you that H plus is the same thing as saying H3O plus. So please do not let them trick you with that. H plus is the same thing as saying H3O plus. So I want to think about this in terms of moves, in terms of do I have more H or do I have more OH minus? And I want to know that this is a logarithmic scale. This is a logarithmic scale. So an increase or decrease either represents a 10 times change in magnitude. A 10 times change in magnitude. So that would mean if I move one time, one move, okay, meaning I go from a 6 to a 7, or a 7 to an 8, a 1 to a 2. If I change my pH, I'm changing how much H plus or OH minus I have. So you can think of these as if I made my pH scale right up here, my pH scale, okay, it goes 0 to 14, but let's just write it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. If I'm looking at my pH scale, one move, if I go from 4 to 5 or 5 to 4, If I go either way, that is a 10 times move. I'll have to know, did it 10 times increase my H plus or my OH minus, but it's a 10 times move. If I go over here and let's say I change from a 10 to a 12, well, I moved over twice. That is 100 times move. If I move 3 times, 10 to, let's say, I can't go higher. Let's go, I'll pick a different color. 10 to 9 to 8 to 7. If I go from 10 to 7, that is 1,000 times move. So what am I doing? All I'm really doing is 10 times 10. 10 times 10 equals 100. So it's 100 times move if it's 2 moves. Each move on the pH scale represents 10 times. So for example, let's say I had a pH of 7, and I want to know it has, I want to say 10 times more, let's say, pH 7 has 10 times more H plus than, I want to think, which pH? pH question mark. Well, 10 times I'm going to think is 1 move. I have to have more H plus, so I want to go down my scale, because as I become more acidic, I have more H plus. So I moved from a 7, no wait, plus. I read that wrong. pH 7 has 10 times more. Okay, so the 7 has more H plus. The 7 has more H plus, so it has 10 times more H plus than a pH of 8. Think, because if you're looking up here, 8 versus 7. 8 is moving on the basic side, so it's getting more OH, less H. 7, I have equal amount. So as I move down my scale, I get more H plus. If I did, for another example, I said, okay, let's stick with the pH of 7. A pH has, let's say, I'm going to have us figure out how many times, and is it more or less H plus than, let's say, pH 4. So let's think. I'm going from 7 to 4. So let's think how many moves. 1, 2, 3. 3 moves. Well, then I'm doing, I'm doing 10 times 10 times 10. So 7 has 1,000 times, let's think, more or less H plus. Well, pH 4 is more acidic. pH 4 has the most H plus compared to 7. So 7 has 10 times less H plus compared to a pH of 4. Let's look at this example and see if we got it. Calcium hydroxide is commonly known as agricultural lime and is used to adjust the soil pH. Before the lime was added to the field, the soil pH was 5. After the lime was added, the soil underwent a 100-fold decrease in the hydronium ion concentration. They asked me, what is the new pH of the soil in the field? Well, remember, hydronium is H3O+, which is the same thing as H+. So they're basically saying I had a 100-fold decrease in my H+. So I had less H+. It started at a pH of 5. Started at a pH of 5. So I went from pH 5 let's think, if I do 100, well, that's 10 times 10. That's 2 moves. So I have less H plus, I got to move up. I went from a pH of 5 to a pH of 7. Well, actually, Hutch, say hi to everybody.
Hi, everybody. Hope
Well,
you're
very
working
fast.
hard, as hard as your teacher is.
Woo! Okay, so we're back. And actually, this part, lucky you do not have to do. That is gone. We just have one last little thing. We are going to talk about pH indicators using table M. So, let me get a table M here. I got one big. On table M, how I use this. For instance, if I'm looking at, let's say, phenolphthalein. If I look at phenolphthalein, I have my approximate range for color change, my 8 to 9, and I have my color change, colorless to pink. That means anytime you're at a pH higher than 9, it's pink. Anytime you have a pH lower than 8, it's colorless. That is very important, okay? Your color change, the range is the range where that change happens. When I'm outside the range, that's where I get the colors. So every time it says colorless to pink, yellow to blue, it means below the pH range is the first color, above the pH range, it is the second color. So if I'm looking here, it asks me about methyl orange, I believe. Methyl orange, it says remains orange between a pH of. So I just go here, and I say, well, methyl orange, it's orange between 3.1 and 4.4. Oh, I lost it. I'm going back right. 3.1 and 4.4. When it is less than, I don't know why I have that blank. When it is less than 3.2, methyl orange, let's look. When it's below here, it will be red. When it is greater than 4.4, methyl orange will turn yellow. The second color that is listed. I can also use a combination of indicators. We will go to the next page, and I will show you that. So it says, in lab, you place bromocressyl green in a solution, and it turns blue. So the pH, solution has a pH greater than. So I go over here and say, okay, bromocressyl green. Now be careful, you're grabbing the right one. Bromocressyl green. It is blue anytime it is higher than 5.4. Anytime it's higher than 5.4. So I say, okay, when it is greater than 5.4, it's blue. In a separate test tube, you have the same solution, and you add bromothymol blue, and it turns yellow. So the solution has a pH less than. So go back over here and say, okay, bromothymol blue, it's yellow when it is below 6.0. So go back over here. So the same solution has to be somewhere then between those pHs. It's got to be greater than 5.4, but it's got to be less than 6.0. So the overall pH got to be somewhere in between. So between 5.4 and 6.0, somewhere in there. So I can use multiple indicators to decide what my pH is. And that's it for the notes. So you do need to do, now that you've watched this, I told you I was going to embed a textbook assignment. It's page 181 to 182. You have to put number 37 to 39 on a separate sheet. That is very important. I mean that. Put it on a separate sheet. And if you need any help, you can read the pages before. Other than that, I hope this video helped. Hope you have a great weekend, and I will see you Monday.